Okay, great. So let's start off with the webinar while others join during as we move forward. Okay, thank you guys for joining today's webinar. This is the third webinar by Deepstream, and today we'll be talking about the security concepts and features in Deepstream. So I'm going to be sharing my screen real quick. Okay, great. So today we'll be talking, as I said, about Deepstream security concepts and features. I'm Srushtika Neelakantam, and I'm the developer evangelist for Deepstream Hub. And during or after the talk, feel free to tweet me questions or email me after the talk if you have any questions. And since there are a lot of concepts, security concepts we'll be covering today, we have three. I have divided the webinar into three main categories, and I will pause and ask you and check if you have any questions, because as it's a webinar, I can't see any of you. So if you have any questions, I'm going to check after each section. So make sure to put in your questions in the chat section as we move forward in the webinar. Cool. Let's get started. So Deepstream's security is divided into three major aspects. These are the encryption, authentication, and permissions. Let's have a look at each one of them, what they are, and how you can implement them inside your applications. Now, it's worth mentioning before we move forward that today's webinar is going to be generic to both Deepstream IO and Deepstream Hub. So as we cover different concepts, I'm going to let you know which feature is available in which of the products, so you can use it accordingly based on what you have been using until now. So now, what is encryption? We all know what encryption is. Basically, any two entities on the internet, if they are to communicate with each other, they need to be sure that their data is not being stolen by someone else. If the data is freely flowing, it's at a constant risk of attack by some person who's sitting out there trying to steal the information and make malicious use of it. So in a sense, if we have a client and a server, and the client is sending some data to the server, the man in the middle, who's the attacker, tries to steal this information, and we wouldn't want that to happen. So what we do is we encrypt the data. Now, if we encrypt the data basically is not in clear text. So even if the attacker gets access to that particular data, he cannot understand any of it. He can't make sense out of it. So he's basically confused. That's the whole point of encryption, right? And this particular kind of attack, as we all know, is known as the man in the middle attack, right? So what exactly happens when you try to encrypt a particular connection? So you have a client and a server, and when the client is requesting the server for a connection, the server sends its public key along with its certificate. Now, public key and certificate, two new terms. Now, public key is basically now all this encryption works based on keys. Every entity on the internet has a public key and a private key. Now, if I want to encrypt some information which I intend to send it to this particular server, I would use this server's public key, encrypt it, and then send it. Now, what happens here is, since I've used the public key of this particular server, only that server which has its own private key can decrypt it, and no one else can. And since the private key is not shared with anyone else, my data is basically safe. So when the server sends its public key along with the certificate, the first thing that the client does is it verifies if the certificate that the server sends was indeed generated and awarded by a certificate authority. Now, it's not necessary that the certificate authority is the root certificate authority. We have this tree hierarchy of different, certificate authorities which award a certificate. A certificate is basically a way to identify a particular entity on the internet as authentic, and in a way to say that this particular entity is not claiming something which it is not. So after that verification is done, the client will utilize, as I mentioned, the public key of the server, encrypt the data that it wishes to send, and then send it to the server. Now, since the server only has its own private key, only the server can decrypt it and nothing else can. So spoke about this, we have three main aspects in any encryption process: the certificate, key, and the certificate authority, as I explained. Now, encryption in deepstream. What happens in deepstream? So, deepstream uses two main encryption algorithms, which is the transport layer security and secure sockets layer, TLS and SSL, to encrypt all the data that travels between the client and the server. So, and all the communication that happens between the client and the server is done using WebSockets. Now, in case of Deepstream Hub, the once the connection is established, it's basically on WebSockets, but it automatically is redirected to a secure connection, and hence it functions over WSS. But on the IO, it does not automatically redirect it to a secure one, and you need to mention it yourself. So let's see how to do this on both Hub and IO. So on Deepstream Hub, you of course have the so you can verify it here that when you're connecting to a Deepstream server using your client, you give your app URL, which basically starts with a WSS, which tells you that the connection is indeed over secure WebSockets, right? So as I was mentioning, in Deepstream IO, you have the configuration file, right? Now in that configuration file, if you want the connection to be secured, that is on WSS and not on WS, you would require to generate a SSL certificate and link that at this point in your configuration file. Now you can either get your certificate from a particular certificate authority, or you can self-generate a certificate. There are a lot of tutorials and sites to go and check how you can generate your own SSL certificate. So once you have generated the SSL certificate by either of the two methods, you will get three different files. If you have generated it yourself, you would of course not have the certificate authority, but you will have the other two, which are the SSL key and the SSL certificate. Now, what you have to do in order to make the connection secure is to link these files at this particular place in the configuration file of your Deepstream IO server. So by default, these three keys are null in the SSL in the configuration file. So once you link it, and after that, if you connect it to the server, it's secured WebSockets. Cool. Okay. Now, one other thing which is very interesting that happens in Deepstream is the encrypted data that travels from the client to the Deepstream server needs to be decrypted, of course, in order to perform any other actions on it. Now, this decryption process can be done at two different places. One place which is very straightforward, is directly at the Deepstream server, as you would imagine. But there is also another point at which you can do this decryption process, which we call the reverse proxy. Now, what happens in reverse proxy is you're basically decoupling the Deepstream server from the decryption process. Now, as we all know, decryption is computationally very heavy. What if I took away that much amount of work from the Deepstream server and let it do other tasks efficiently, because it is a bit free now, and it is not doing or responsible for decrypting the information as well. So that's what my reverse proxy does. It serves as a transmission endpoint for all my TLS and SSL algorithms, encrypted data. And reverse proxy is the place where all my information is decrypted. And from that point, the decrypted information flows directly to the Deepstream server, where your app logic plays, and basically all the other operations on the data are done then. Now, this reverse proxy and the Deepstream server are said to be part of the same trusted internal network, right? So even if it is decrypted, you don't basically stand a risk of having an attack inside that. Now, one more advantage of using a reverse proxy is it also offers load balancing capabilities. Now, what is load balancing is, if you have like more than one server, you would want all those servers to function at the same capacity, right? You would not want to completely load one server with all the different operations, and while the other server is still idle. So the load balancer ensures that all of them have the equal traffic. You can incorporate that functionality as well in the reverse proxy. Now, what are the different kinds of servers that we can use as a reverse proxy in this particular deepstream application, or any deepstream application basically? So we have the Nginx, HA proxy, Apache, most of the J2EE servers like the Tomcat and Daybox, and also the Amazon Web Services Elastic Load Balancing. Now, one thing which is very interesting about AWS Elastic Load Balancing is it does not only provide the reverse proxy security features that I just mentioned, but it also provides the load balancing feature also for free. So you can basically use that with all your applications, and it provides some part of it for your personal applications. So I think that's the best option out of all the servers you have to use as a reverse proxy. Cool. So that was all about authentication. And before I move forward, I'm going to check if we have any questions in the room until now. Okay. No questions for now. Okay, great. So let's move forward. And if you have any questions further on, you can, of course, mention them later as well. So the next main aspect in deepstream security is authentication. Now, deepstream has different kinds of authentication that you can use to authenticate clients into your deepstream application. Now, depending on whether you're deepstream IO or deepstream hub, only few of these are available in either of those. Not every authentication type is available in both of them. And I will mention which is available in what. But before moving on to that, let me mention what exactly happens when your client connects to a deepstream server. So in your code, you basically say const client equals deepstream, and you would write your app URL. That's what you do for every deepstream application, right? What happens at this point? The connection between the client and the server is established, and nothing else. That's it. So the client at this point is said to be in some kind of a quarantine state where until the time the client is authenticated successfully. And authentication will be done by calling the login method on the client, as we will see further down the webinar. So we have 5 main types of authentication mechanisms. It's the no authentication, file-based authentication, token authentication, email authentication, and my personal favorite, the HTTP webhook authentication. Cool. So no authentication is available only on both Deepstream IO and Deepstream Hub, whereas file authentication is available only on Deepstream IO. Now, the token and email authentication are only available on Deepstream Hub, whereas the webhook authentication are available on both again. So depending on which of the products you use for your application, you can choose the authentication mechanism you want. So moving forward, starting with the no authentication. In no authentication, as it is completely clear and straightforward, the icon and the name itself, it's basically no authentication at all. You do not authenticate the users. It's like a public garden where people can walk in freely, right? So let's see how you would implement that in your application. When I have the client, I'm connecting the client to the deep stream using the deep stream client equals deep stream, and then you include your app URL like you do it for every other application. Then I would call the login method on the client, and I would not send any auth parameters at all because it is no authentication. Now, do I need to have a login method at all? Because I don't need to have any authentication. Well, for any kind of deepstream application, you must have a login method, which is necessary even for no authentication. So you may choose to pass the empty curly braces without any auth parameters, or you may completely skip that particular parameter and directly go to the callback function, which has a success parameter, which will always be true if your connection was successful, because at this point, we do not have any auth parameters which are being validated. So there's no way the success cannot be true unless your connection had some problem, right? So why would you even use no authentication? Why would I have any application where I would let any users just walk in and use my application? Applications like, so if I've built a dashboard which is showing the score of a football match which is happening live in the stadium right now, and people from all across the world would want to see what's the score. So I have the dashboard and I cannot expect people to log in before they look at the scores. It's just a public dashboard with publicly displayed data. That's it. That's the kind of applications where you would use no authentication. Makes sense, right? Okay, moving to the next authentication method, we have the file-based authentication. As I mentioned, file-based authentication is available only on deepstream IO and not on Hub. Now, in file-based authentication, you would essentially have a file full of user credentials. So if you have fairly lesser amounts of processes that provide data to your application, file-based authentication is useful in such scenarios. So let's have a look at an example user file. So I have two different users whom I am identifying with their usernames. So I have John Doe and Sam Jones. I have password for both of them, which is of course hashed, as you can see. And then I have two different bits of data, that is client data and the server data, which are different for both of the clients, right? Now, I would talk about what client data and server data essentially means further on. But let's have a look at how you can include this particular user file to be used as file authentication in your client when you have your application under deepstream IO, of course. So for file-based authentication, you would go to the configuration file to the auth section and mention the type as file. And in the options, there are 4 different options: the path, hash, iterations, and key length. In the path, as is clear, you would give the path to the user's file, which you've written in the YAML structure, which I just showed it to you. So that's my path to the user's file, where I've listed down all my users whom I would like to authenticate into my application. Hash is the hashing algorithm that would be applied on a clear text password using Deepstream's own client command line interface, which comes inbuilt with the Deepstream server when you install it via the package manager, which I would show you in a bit. So you have the hash algorithm, which is MD5 in this case. The iterations are the number of times you would want to apply that particular hash algorithm. And key length is the length of your key, the resulting key that is supposed to come out after applying all this hash algorithm and the number of iterations. And as you can see in the user file, we have 32 bits of the length of the password, hashed password is 32 bits. So how would you create this kind of a password? As I mentioned, Deepstream's CLI tool, which is inbuilt when you download Deepstream server using any of the package managers. And if you go to the command line and say Deepstream hash and give it a clear text password, it just returns you a hashed password by which has all the attributes which you mentioned here in the configuration file under the auth section, right? So in file-based authentication, now on the client side, how will I make the client login? Because I had mentioned John Doe as one of my users in the user file, John Doe would be successfully authenticated if he provides the username as John Doe and the password as what is mentioned here. So let's have a look at it. I would call the login method on the client. Of course, the login method always comes after you have established a connection. So in the login method, inside the auth parameters, I'm sending the username as John Doe, which is correct, which we saw in the file. Password, we are not going to check the hash password, it's way too long, but let's assume that it is the same as what was mentioned in this particular file. And we have the 2 parameters in the callback, which is the success and the data. Now, success will be true because we have this particular username with the concerned password listed in our user file. If it was any other username or any other password, or if there was any other kind of mismatch, the authentication would have failed. Makes sense, right? Now, inside the callback, we have 2 different parameters, the success and the data. Success, as we have already seen, is either true or false. It's a Boolean variable, letting you know if the authentication was successful or unsuccessful. Now, this data is what we mentioned in the client data for every user. Now, this client data and server data are going to come in every authentication type, except for what we saw as no authentication, because in no authentication we don't really have any user, so no point in having some kind of data associated with a particular user, right? So for all the other kinds of authentication types, we have client data and server data, which is different for each different client or user. So this client data, which I have here as render color brown, this can be obtained using the data variable that is available in my callback function. Cool. Moving on, we have the token authentication next. Now, we see a lot of applications nowadays use token authentication. In token authentication, what we basically do is your server creates a string, a piece of string, which is a unique token, and it gives that it allocates that to each particular user, and now the user can log in using just the token and no other auth parameters. So if you have a lot of backend processes which are working with your deepstream application, token authentication would be the best option. So how would you how would you implement token authentication? Is via the dashboard on Deepstream Hub. And as I mentioned before, token authentication is only available on Hub and not on IO. So if you go to the auth section on Deepstream Hub's dashboard under your application, you have something called token. Now, it's worth mentioning that for every application on Deepstream Hub, except for open authentication, which is basically the no authentication, every other authentication type is by default disabled. So you'll have to explicitly enable it before you use it. And then you say for token authentication, you add a token, give it a particular name in order to identify different tokens using the names, and then give it client data and server data, as is the case with all kinds of authentication types, right? And then if you say add, Deepstream will generate a particular token which you can copy and ask your client to log in with. Now let's see on client how this is made possible. I will call the login method on the client like always, and I would say token, and I will send that particular token which was generated by the server for this particular user. And again, we have success and data in our callback. Success will be true if the authentication was successful, false if it was unsuccessful, and data here will contain the client data which we mention within this section in the JSON format, of course. And server data is something that I will cover further on in the webinar. Cool. So next we have the email authentication. Now email authentication, just like token authentication, is available only on Deepstream Hub and not on IO. And email authentication is, I think, the most straightforward authentication. You just type in your email ID and the associated password that you have your Deepstream account associated with. So now on your application dashboard, as I mentioned, every other authentication type is disabled by default. So you'll have to enable it first before you use. And even if you try using it without enabling, you'll automatically get a prompt to enable it, saying that it is disabled. Cool. Now, again, like any other authentication mechanism, on the client, we will call the login method. And this time we would send two data pieces, which is email and the password. And then I have the callback function, which has the success and the data, right? Now, how do I know that this particular user with email, srushtika@test.com, and password with some password needs to be successfully authenticated? So as the administrator of the application, you need to add in users to your application, right? Like you did in the file auth, you added two different users in your file, and then you linked that file in your configuration, which was in IO. So similarly, you would want to add different users and type in and give their email ID and password and save that in your application. So Deepstream knows that, okay, these are the users which are under your application. You have added them yourself. So these can be authenticated successfully. Now, adding the users can be done in two different ways. One is directly from the dashboard. If you go to the users tab on the left pane, you have a button saying add user, and you can give in the email ID and the password of a particular user, of course, along with the client data and the server data, which is associated to each different client. So there's different data for different client, right? Now, another way in which you can add users is using Deepstream's HTTP API right from your command line. You would just do a curl and a post request with the content type application/JSON as is shown here. And within the body, you would have each different object for each user. One extra thing here is that you will have to mention type as email, and then this is one object adding one user, and I can have many different objects adding many different users simultaneously in a single request. And at the end, I would add the HTTP base URL, which is https://api.deepstreamhub.com/api/v1. And in order to add users, we need to build the URL in such a way which has user auth sign up :API key. This API key is of course obtainable from the admin tab under your dashboard, on your Deepstream Hub dashboard under your application. So you can just give the API key, and that's how you would add users using the Deepstream's HTTP API. Clear? Cool. Now we have something interesting that happens in email authentication. As part of email authentication, we have something called session tokens. Now session tokens are a bit different from the token authentication that I mentioned before, because that token is valid forever. But this particular session tokens are returned every time your client logs in using email auth. And each token is valid only for a period of 24 hours, and it becomes invalid after that. But during the time that it is valid, your client can repeatedly log in using just the token and not provide the email ID and password every time. So how can we utilize this? Let's have a look at a small application which utilizes session tokens as part of email auth. So in session tokens, we will use local storage to store the token temporarily and retrieve it whenever the client wishes to log in. So I would say token equals local storage.get item, assuming that it was already stored. And I have given the session token name as Deepstream token. Now, initially, I'm checking if the token exists at all. So this is the place where I check if the token exists. If it doesn't exist, it means that the user is logging in for the first time. You don't have a token at all, which is stored in the local storage. So you would say log in with email if the token doesn't exist. But if it does exist, you would try to resume the previous session by passing in the token that you retrieved from the local storage. Okay. Now, in resuming the session, when you're passing the token, you will attempt a login on the client by passing that particular token as part of the token variable in your auth parameters. And if the authentication was successful, you know that the token was valid and hence it is successful, you would directly go to the main page of your application. Otherwise, you would understand that there is a token that exists. You tried logging in with that token and the authentication failed. It means that the token has expired, basically. It is more than 24 hours have elapsed since the token was generated. So you will go back to logging in with email as usual. But while logging in with email, you would retrieve the email ID and password from the client using the window tools of your JavaScript, and then pass them in the authentication parameters. But this time, make sure to set the Deepstream token with the token that is returned by the server in the local storage. So it is handy when you want to log in next within 24 hours. So it goes back to this, and it's like it keeps on following this order. If there is a token that exists, it will try logging in with that. If it is valid, all the better. If it is not, it will go back to logging in with email ID, and the new token which is generated, it will save it back on the local storage. So it is useful if you want to log in again. Straightforward, right? Neat. Now it's time for webhook authentication, which is very interesting type of authentication. Now in webhook authentication, what happens is, imagine that I have a application which I've been working on since a lot of months. And now I have different users coming into my application, which is written in some language. I do something in my application, but I have these users and I have made a database of all these users in order to, authenticate them into my application. It's nowhere related to Deepstream as of now. But now I decide to integrate Deepstream to add some real-time functionality in my application. Does that mean that all the users who were authenticating into my app until now using my database, I will have to I will have to list all of them down in one of these files or something for using some kind of authentication. I don't really have to do that. I can still keep using that database, and I can actually write my own authentication logic and just tell Deepstream, see, this is the user I know, just let him in. This is someone I don't know, don't let him in. Let's see what basically happens in webhook authentication in order to understand it better. So as usual, you have the client and your Deepstream server. Now, client initially sends the connection request, and if the connection is successful, the client will next send the auth parameters to the Deepstream server, right? Now, what Deepstream server does in case of webhook auth is you have a HTTP auth server of your own. Deepstream server just forwards the auth parameters along with the connection info of the client, like the HTTP, like the IP headers and cookies, etc., using which the client connected to Deepstream server inside of a post request to your HTTP auth server. Now, what happens is the complete logic of whether to authenticate or not to authenticate this particular user lies in your HTTP auth server, which you have written in your favorite language and which uses your own backend, like some database which you already have and things like that. The only thing that your HTTP server does it returns a response code back to the Deepstream server. And depending on what kind of HTTP response code was returned, Deepstream server will know that you want to allow this client or you don't want to allow this client. If the HTTP, if you want to allow that client, obviously you will send client data and server data back to Deepstream server, and the client data part will be given back to the client as part of data which is sent in the callback function. Now, in Deepstream Hub, you have only 200 as a status code, which is accepted as success by the Deepstream server, and any other response code basically means that you have denied access to that particular user. So if you have accepted, Deepstream server basically lets the client in, right? So what exactly happens on the client side is we send the login, we call the login method on the client and say type is webhook, since we're using webhook. Next, what are the other different things that the client needs to send as part of auth parameters? It can be anything. These parameters basically have to match the parameters that your HTTP server is expecting to be received by the client. It can be username, it can be age, it can be city. It just depends on the logic inside your server, right? Let's have a look at one small example of a server and how you would build your own, authentication server, and how all this would make sense. Okay, before that, on Deepstream.io, as I mentioned, there is the configuration file, and you need to mention an endpoint URL, which is the URL you will use to speak with Deepstream, right? So the Deepstream will use this particular URL, which is your HTTP auth server's URL, in order to send you the post request. And only in IO, Deepstream IO, you can set different kinds of permitted status codes. It means that it's not just limited to 200 now. I can decide that I would send you a status code of 403, and you would still have to accept it. I can tell Deepstream that by including that particular status code in this array of permitted status codes. Whereas in Hub, it's only 200 that's allowed, and you would again mention the webhook URL on your dashboard after you have enabled webhook auth, of course, because if you remember, it is disabled by default. Okay, so getting back to our example of a simple express server. So you initialize the server and you do all those things. Now you have now if the Deepstream server is doing a post request on the login path, you have the request and the response. And my server is now checking if the body inside the body of request I have the auth data, email part of that auth data as webhook@user.com, and the password as password. Only if my request sent by the Deepstream server, forwarded by which is just sent by the intern by the client, has webhook@user.com and password, I will allow the user. If it is any other auth parameter or some different kind of an email or password, I will not authenticate the user successfully. If it is these, I would send the response in JSON format and say user ID is blah, blah, blah. And I will, of course, send client data and server data. Client data will again be sent back to the client, which the client can utilize inside the app logic, whereas the server data will be retained within the server, but will be associated with each particular client. So this server data is associated with one particular client, which is webhook at user.com only. Another user will have another server data, but it is retained at the server and not returned back to the user. Why? We will discuss about that in a while. And then you say if else, that means your email, your auth data did not contain these two data pieces, then I would send some other response code, and my deep stream will be smart enough to understand that you're basically trying to reject the user from being authenticated successfully. That's it, simple as that. Now, what else? As I've been mentioning, we have client data that we included with every kind of authentication except for no auth. So what client data is, you have some particular data for every client, like the theme color and layout config as shown in this example, which is returned back to the client that the client can basically utilize while performing the application logic. And apart from this, there are two other pieces of data which are implicitly returned by deepstream as part of client data. These are the ID, which is the unique ID of each user, and the token, which is returned in case of the email auth, as we saw. Now, these pieces of data can be utilized as part of the data variable, which comes in the callback function. So if I wanted to display theme color on my HTML page in the front end using JavaScript, using the client side JavaScript, I would say data.themecolor, and I would just display it, and it would display blue because that was sent back to me as part of the data variable, and I can utilize any of the objects within that using that particular variable. Cool. Okay, we are now at the third aspect, which is permissions. And before going here, as usual, I'm switching back to check if there are any questions until now. Do we have any questions for all the authentication mechanisms which we saw? Cool, no questions. So I'm gonna continue with permissions, which is the third and major aspect in deepstream security. So basically, why would anyone use permissions or rules anywhere? It's basically to maintain harmony between everyone, right? So for instance, if I let anyone in my organization do all kinds of things, it would basically be a chaos and things will be screwed up by the end. So I need a way to ensure that only specific people are allowed to do specific things and others are not. So deepstream's way of doing it is called permissions, and it does it using something called valve. Now, Valve is a rule permissioning language specific to Deepstream, and it looks something like this. You would have come across this on your Deepstream Hub's permission section or on your in the permissions file on Deepstream IO, right? So now, all this doesn't make sense to me at all. Let's break this down and try to understand what each of these things mean and how you can write your own permissions in order to make things work perfectly fine in your application, right? So, any particular permission has is a hierarchy of three different things. There is a type, within each type, there is a name, within the name, there is an action that you want to perform. So type can be anything out of the four different features that Deepstream has, which are, as you already know, records, RPCs, events, and presents. Name is the name of that particular type which you mentioned. So if I say record, I would mention the name of the record for which I'm writing the permission for. And action is what I'm doing to that particular record. Let's have a look at an example. I have a record, which is the type, and I have the name of the record, which is user/star. That means any record which starts with user/, and it can contain anything after that, which is basically the meaning of asterisk, like the SQL, like in the SQL format. So I have the name of the record user/star, and I'm doing the action, which is read equals true. So I'm basically setting a read equals true access. Basically, I'm allowing everyone to read the record by the name user/star. So everyone is allowed to read this particular record in my application. That's what this permission means. It sounds vague, it sounds very easy, and does not sound so powerful. Is that what all permissions do? Let's see how powerful it is and what all you can do with the permissions. Before that, as I mentioned, there are 4 different types that you can write permissions for. And within record, you can write permissions for to decide who gets to create records, who gets to write, read, and delete records. For events, you can decide if who gets to publish and subscribe to events. For RPCs, you get to decide who gets to provide an RPC and who gets to request it. And in presence, you can decide who gets to allow presence. Now, what allow presence basically means is, if you have allowed presence, only then, if the permission says that a particular user's presence is allowed, only then will you be able to see the online status of other users within the same applications. Otherwise, you can't use presence and see the online status of people in your application. Make sense, right? So how does this thing work at all? Now, as I've been mentioning, there was some other data as well in all our authentication mechanisms, which was a server data that I basically skipped the explanation for. And here is where I'll explain that. So we have server data in which we will include all kinds of important data like the role and access level for each particular user, which will be utilized basically for writing the permissions and nothing else. So in a deepstream client, let's have a look at an example where I'm trying to do something, and if I have certain permissions, I'm allowed to do that. If I have certain permissions, certain other permissions, I would not be allowed to do that. So in my deepstream client, I have the system settings variable where I'm getting a record by the name system settings. Now on this record, I'm setting max file storage as 20 GB. That's what my client is doing. But in my permissions file, either on IO, which is a permission file, or if you're working on Deepstream Hub, it is on your dashboard in the permission section on the left panel. I have a permission which says record. The name of the record is system settings, and write is user.data.role equals admin. What does this mean? This basically means that if the role of the user who's trying to do something, manipulate something with this particular record is admin, only then will that particular user will be allowed to write to the record. No other user can write to the record. And in this example, our role is admin, of course. That means this request by the client that is setting 20 GB to max file storage within the record name system settings will be successful. Right? Now, what is this user data and things like that? I just know role from the server data, but how have we written this? Now, with Valve, we have access to 5 major variables using which we can write the permission rules. Let's have a look at each one of those. First thing, of course, is the user, which we just utilized. In user variable, we have 3 different variables, which is authenticated, which is true if the authentication was successful and the user is basically authenticated. The ID is the unique ID of each particular user, and the data. This data is basically nothing but your server data, as we already saw. So within the user, within the data is what we have role, and that's exactly what we had mentioned here. Within the user, within the data, the role equals admin, which was true, right? So here, I'm trying to manipulate the company data, the record by the name company data. And who can manipulate company data? In this particular use case, I want only the people who have access level greater than 2 to do that. So my particular client now has the access level 3 according to the server data I have for the particular client. Now I'm setting the record. I'm getting the record. I'm reading the record by the name company data. And in the permissions, I have record, name of the record, which is company data. I can allow only those people to read that particular record if their access level is greater than 2. So again, it is user within that data, within that access level. User data access level is greater than 2, which is true in this particular case because the user has the access level 3. So basically, the user gets to read the company data, the record by the name company data. Simple as that. The next variable which we have is the data. Now, data is not the same as the data which we have here. This was within the user variable, we had something called data. But this particular data is a standalone variable, which basically means the data that you send, that the client sends to the server while doing a particular action. For instance, if I'm emitting an event, I send some data. This data is accessible in the permissions file using the variable data. If I was writing to a record, I would again send some data. Now that piece of data again will be accessible to me with the use of the variable data. So in this example, we have some variable, say my page likes, which counts the number of likes on my Facebook page. Now my client wants to emit the event, add a verify marked on my page, and is sending me the number of likes I currently have on my page. Now at the server on my permissions file, I have a rule which says event, name of the event, which says verify page, which is not exactly correct. It should have been add verified mark uh, because that's what the event we have here. So, okay, let's ignore this inconsistency and imagine that this particular name was indeed add verified mark. So, event, name of the event, add verify mark, and I would say emit only if data.page likes is greater than 50. And let's imagine that the likes on my page are currently 60. Only then this particular this particular event will be emitted. Otherwise, it will be rejected and it'll throw an error. So how am I using data here is because I'm sending this particular piece of data when I'm emitting the event, this variable is accessible using data variable, as I mentioned earlier. Cool. Next, we have something called old data. Now, old data variable is available only to use with records and not with the other three types. Why only with records? Because records can store some particular information, whereas the other three cannot. And old data is exactly that. Old data is what data you have currently associated with with the particular record. Whereas the data is what's the new data the client is sending as part of the request to the server, right? So let's see an example. My client here is saying client.record.set data. I have this name of the record as auction/54, and I'm sending some data which is current bid as 50 with the value of 50. Whereas that particular client already had a record with auction/54, and the current bid in that record was 20. What if what if I want to allow the client to bid for a bid only if he's bidding for a higher price than what was already present? I would then use old data variable. So I would say record auction/star, which is basically any record that starts with action. And I would say write only when data.current bid, which is basically 50 in this case, is greater than old data.current bid, which was 20, assuming that this was the data in our existing record, which is true in this case, and hence this particular record will be set. Now the current bid will contain 50. Cool. Next, we have the variable now. Now is pretty straightforward. It is basically the current time in milliseconds. Why would you utilize now? Let's have a look at an example. In my client, I'm choosing a particular time for delivery of some package, right? Which I'm storing in my time variable. Now in client, I'm setting a record with the name. I'm setting data in a record with the name DHL/Berlin, and I'm setting this particular data, which is delivery time, as this time that I desired the package to be delivered at, right? Cool. Next, in my permissions file, I have the record, name of the record, which is DHL/Berlin in this case, and I'm writing an action for write, and I would say data.delivery time is greater than now. What is exactly happening here is data.delivery time basically gives me this time within my permissions file. Now, I'm allowing the client to set the data in this particular record only if the delivery time chosen by the client is greater than the current time at which that particular set data is happening. So I can't request DHL to deliver my package yesterday, right? It has to be greater than the time the current time. So that's what this permission record does, and you can use now in all these kinds of situations. Next, we have something called the variable name, the last variable which we have. So now in your client, whenever you are sending any particular data, setting the, for instance, in this particular case, we are setting the data, writing to a particular record with the name user profile / user ID. Now, this particular user ID is my user ID, which is unique to this particular client. But I want this user ID to be sent as well for it to be tested in the permission within the permissions file. What would I do in that case is use something called the variable name. So in the name of the record, I would add a $sign, and this becomes my variable name, in which I can access real variables from the client's request. So here I'm sending a user ID, which will be obtained within the user ID, $user ID variable, which I can still utilize in my action of the permission. So I would say write, I would say user.id equals this user ID. So this basically means that who can set the data in my user profile? Only I can set the data in my own user profile. So that's basically checking user.id, which is obtained from the server data, if it is same as the client's ID, which verifies that the person who's trying to set it and the person whose data is being set is the same. Cool. Now on your dashboard, you have, as I mentioned, on the left pane, you have a permission section with a permissions file. And you can basically go there and edit your permissions file to include any of your permissions. Permissions are written, as I said, in the YAML structure, and it is pretty straightforward to write. And in case of a conflict, now what if I had, going back to the initial example which we saw, now in this case, I have an action for a publish function twice for the same event, for the same type and the same event, which is basically all in this case. Which one would my deepstream server accept? It is basically the longest one. So even if it is star, it says publish. If there is some other event, if there is a user who's emitting an event on an event named user status / user ID, that particular user can publish if the user ID is this particular user ID. Right? Makes sense? So I can have conflicts in my permissions file, and this is how it will be sorted out. Now going back, we have different string functions available to be used within the val file. There are 7 of them, which is starts with, ends with, index of, match, 2 uppercase, 2 lowercase, and trim. Now all these are as the name of them are, it's just very straightforward string functions. And let's have a look at an example of how we would utilize them within the rule permissions. So here we have an RPC, which is the type. We have the name of the RPC, which is book purchase in this case. And I would say request. Only if the data.card, now data, if you remember, was the server data. Within that, I have a particular card and I have a particular issuer for each card. Now I'm checking if there is a issuer that exists for each card within the server data, if it exists at all. Otherwise, it will basically blow up. This rule will blow up if it doesn't exist at all. And then I'm checking if the issuer is Visa. Only then I'm allowing my client to request this particular RPC, which is book purchase. Now, how will I check this Visa is after converting it to lowercase. Simple as that. And in a similar fashion, you can utilize all the other string functions which are available to use within Valve as well. Cool. Now, what's even more interesting than all the permissions we've been looking at until now, we have some feature which is a very powerful feature in Deepstream called cross-referencing. What is cross-referencing and what would you use it for? Cross-referencing, as you can see, the syntax of it is a underscore and a pair of parentheses. You will utilize cross-referencing to reference a different record within your permission rule of concerning a particular client. Now, I'm not sure if what I'm talking makes sense until we look at an example, right? So here's an example of a simple cross-referencing. We have a record. We have the name of the record, which is car sales / start. And I have the action of the rule which says write. Now in write, I want to check if the particular car exists and if the price of that car is less than what I'm offering. So when booking a new car sale, make sure that the cars that sold exist and that its price is the same or lower than what the customer is charged, right? So how would you do that? Now my car's details are not present in this particular record. It's not present in car sale. So I can't make use of the variable names. So I would use cross referencing, and within this underscore and within the parenthesis, I would write the name of the record which I want to reference, which in this case is the data.car ID. And I would check that that particular record exists first of all. And if it exists, I will check the price part of that record and check if it is less than or equal to the price of this particular uh, write request that the client is performing right here. Now this is pretty simple. Now why is it powerful, and what other instances can you use it for? So here's another example of how powerful cross referencing actually is. So in this example, I have a client who's basically setting the data of a record which holds the permissions of the user. Now I have the record name of the record is permissions slash the ID of the particular user, which is data.id. And I'm passing in two different pieces of data, which is can comment, setting it to true, can delete, setting it to false. In my permissions file, I have the record. Name of the record is permission slash star. And I would say write only if user.data.role equals admin. We have already seen this particular kind of an example, and it all makes sense to us right now. So we are basically letting only the admin set any kind of data in the permissions record, which is all accepted and clear. Now, what happens next is if the client makes an RPC saying add comment. Now, my client wants to add a comment, some comment, and then there is some response. Now, when can the particular client make an RPC? This will be determined within my permission section for the RPC, add comment. So I have RPC, add comment, and the client can request an RPC only if the can comment flag of the particular client was true. But that particular flag is available in permission slash in the record named permission slash star. How would I reference it? Of course, using cross referencing. So I would say underscore within the braces, I would add in the name of the particular record, which is permission slash user ID, which is the user ID of the particular user. And then I will check can comment equals true. If yes, then of course my client can request an RPC. And one thing to note about cross-referencing it is if you have subscribed to all these permissions, and if I at some point I plan to change some particular permission, and and one of my client is still subscribed and is still performing some actions, I need to explicitly ask the client to refresh it. Otherwise, I need to kick out the connection of the client and the client has to reconnect, because there's no way in which it automatically refreshes and takes the new permissions within the subscribe. So you'll have to keep that in mind as well. So we have covered all three aspects in deepstream security, and we are all secured right now. So that's it, folks. And as requested by a few of you, I also have a couple of other authentication mechanisms like the JSON webhook auth, the two-factor authentication, HTTP cookies, and OAuth, and how you would implement it conceptually using Deepstream server. I will share these slides after the talk so you can go through them later on, which are basically completely self-explanatory. And as usual, you can feel free to tweet at me some questions, and I'm going to check real quick if we have any questions for now. Cool. Can I use Webhook for Gmail? So if I understand your question correctly, for Gmail, you can use something called auth. So as I mentioned, I have an authentication mechanism here called auth, which is basically for all your social servers like the Google Facebook, all those login via Facebook, login via Twitter, login via Google buttons which you see when you try to log into any applications out there on the web, you all those basically use something called OAuth. And this is basically how you would implement OAuth with deepstream server. There is a client, and the client sends a request to log in to your deepstream server. And of course, we have the reverse proxy. Now, the reverse proxy would ask your Google OAuth server whether to, to give the user's data, so so that your reverse proxy can let your client in and do other operations with the deepstream server. Your Google OAuth server, because it already knows you, because you already have an account on Google, it will ask you if you would allow to give your credentials to this particular HTTP reverse proxy, which is requesting it for the details. If you say yes, give it my data, then it gives it your data and it basically lets you in, and then you're ready to use your application. So I'm not sure if that answered your question. That's how you would basically use Gmail. And Webhook is basically for implementing your own authentication mechanism that doesn't yet exist. Great. Do we have any other questions here? And this particular webinar is being recorded, so it will be available on DeepStream's YouTube channel later on, and the slides will be shared as well. So feel free to look at it again or share it with your friends. And you can tweet to me any questions, or feel free to ask them in the Slack channel that we already have. Cool. Thanks for joining, guys. See you in the next webinar. Bye-bye.